So we have this question over here. This question says, use the sketch and any necessary calculation to prove that sine beta times 1 over tan beta minus 1 over cos beta is equals to negative 12a over a squared minus 9. Now we're given a diagram where there is a right angle triangle where the hypotenuse is a plus 3, the adjacent is a minus 3, the angle you're given is beta, and you are asked to solve this. Now, to answer this question, the first thing we'll do is we'll simplify. We're trying to prove the left hand side, which is sine beta times 1 over tan beta minus 1 over cos beta is equals to this right hand side you see over here. Okay, so let me start with simplification. The first thing that jumps straight to me is tan beta. Tan beta is the same thing as sine beta over cos beta, right? We understand that tan is sine over cos. Now, if you know tan is sine over cos, 1 over tan would be cos over sine because it's the inverse. So I'm going to write it like this. So the next thing I will do is I can cross cancel. I understand that this sine beta can cancel out this sine beta. So all I'll be left with is, another thing that we also know is using trig ratios, cos is x over r, or we can say it is adjacent over hypotenuse, either way. So since we're given a triangle over here, we understand that this can be represented as r, right? Or your hypotenuse, if that's what you want to call it. And this one over here can be represented as x, or we could also call it the adjacent. If cos is x over r, we should also know that 1 over cos is r over x because it's the inverse again. So what that means, I need to write down the value of cos beta and 1 over cos beta by using my adjacent and my hypotenuse. So if I'm going to write this down, this is what I'm going to have. Cos beta is the exact same thing as saying adjacent, which is over hypotenuse. And 1 over cos beta would be hypotenuse over adjacent, which is. Now the next step that follows is whenever you have fractions, we always try to find LCD because that's the logical step when we're working with algebra. So it means that we'll get the LCD of this. The LCD will just be a plus 3, a minus 3. So I'm going to write it like that. The first side of our fraction would be, while the second side of the fraction would be. In the numerator, we can expand our bracket. So expanding this bracket would give you. Expanding the second bracket would give you. In the denominator, you could also expand that bracket, and that is difference of 2 squares, so you can write it as a squared minus 9. Then from there, we simplify the numerator by opening the brackets. Now we notice that a squared minus a squared would cancel out, and we also notice positive 9 and negative 9 would also cancel out. So all we'll be left with is negative 6a and negative 6a. And as you know, negative 6a minus 6a would give you negative 12 over, and that's it. So this is exactly what we were asked to prove for this particular question over here. All done.